An agriculture researcher is estimating the mean length of the growing season in a region. Treating the last 10 years as a simple random sample, he obtains the following data, which represent the number of days of the growing season. Because the sample size is small, we must verify that the data come from a population that is normally distributed and that the sample size does not contain any outliers. The normal probability plot and box plot are shown below. So we can see here from the normal probability plot that all of our dots are between the outside two curves. So we know that that is approximately linear, so that's good, and there's no outliers here. So both conditions are met there. So now we want to construct the interval since we know that's true. So this is a little bit different. So what we're going to do is first go in and type our data into L1. So we're going to do second plus 4 to clear our list, and then stat enter, and we're going to type in our data. So 151, 163, 149, 148, 164, 188, 190, 183, 165, 153. So now that I have my data typed in, I'm going to do second mode. I'm going to do a t-interval just like we did before. So I'm going to go over to test and then number 8 for t-interval. But instead of doing stats, my input is going to be data. So I'm going to go over to data and press enter, and they go down. So our list should be L1 if that's where you typed it in. Your frequency should be 1, and then our sea level in this case is going to be 0.95. So I'm going to go down and change that to 0.95. Go down to calculate and press enter. So we have 153.8, 177. And you'll notice it also gives you the mean and standard deviation there. So you didn't have to actually compute that. So the last part of our problem is we want to know what can be done to decrease the margin of error, assuming the researcher does not have access to more data. So to decrease the margin of error, we could decrease the level of confidence there.